Hi, welcome back to General Chemistry 1. I'm Dr. Fang Xu. Today, let's talk about formula calculations. Now, first we need to know what are the formulas. They are molecular formulas and empirical formulas. For molecular formulas, those are formulas we've been talking about in the previous videos. For example, alkenes can be presented as CnH2n, ethane is C2H4, propene is C3H6, butane is C4H8. All of these formulas have indications of exactly or actual compositions of element. There are 4 carbons in one butane molecule and 8 hydrogens in one butane molecule. But when we take ratios of all of these elements, then we can simplify this formula into CH2. CnH2n, if you take ratios, you cancel out n's, it's 1:2 ratio. C2H4, 2:4 equals to 1:2 ratio. 3:6 equals to 1:2. 4:8 equals to 1:2. So this side on the right is called the empirical formula. It's a simplified whole number ratio of all elements from the molecular formula. From this relationship, you know that several compounds may have the same empirical formula. Although they have different molecular formula, they may have the same empirical formula. So once the empirical formula is obtained or is provided, how can you get a molecular formula? Of course, you probably need some extra information, but what are they? If you take a look at this empirical formula, the difference between the two is you need to multiply each element in the empirical formula by a common factor, either some type of integers, 1, 2, 3, 4, 5, whatever. So in order to get the molecular formula, we need to get these common factors. This common factor can be determined by comparing the molar mass of empirical formula and the molar mass of molecular formula and the molar mass of empirical formula. So that's how we're going to get this factor. Let's take a look at a question. If the empirical formula is CH2 and the molar mass of the molecular formula is 42 grams per mole, what is the molecular formula of the compound? We can use this equation. The molar mass of empirical formula times the common factor equals to the molar mass of molecular formula. The molar mass of CH2 is 14 grams per mole. So plug in the numbers. 14 grams per mole times N equals to the 42 grams per mole of the molar mass of molecular formula. So then you can get N equals to 3. Once you have N equals to 3, you can put the empirical formula in parentheses and write 3 as subscript. Then times every subscript inside of the parentheses with 3, then you can get the molecular formula is C3H6. There's another way we can get the empirical formula. We can get it from the mass percent. So what is a mass percent? The mass percent refers to an element in a compound. So the calculation of mass percent of an element equals to the mass of the element or the molar mass of the element divides the total mass or total molar mass of the compound times 100%. If we take the empirical formula of CH2 as an example, the mass percent of hydrogen equals to the total mass of hydrogen divides the total molar mass of CH2. So for hydrogen, we have 2 hydrogens here. The molar mass is 2, and the total molar mass of the compound is 14. So then we can get the mass percent of hydrogen as 14.3. The same thing with the mass percent of carbon. Then use the molar mass of carbon divides the overall mass of the compound. The mass percent of carbon is 85.7%. Add these two numbers together, we can get a 100%. That means this compound, this empirical formula, is only made up by carbon and hydrogen, right? That makes sense, right? All right. Reversibly, if a mass percent of each element is provided, then we can use this to calculate the empirical formula. Take this as an example. If we know the mass percent of hydrogen is 14.3 and mass percent of carbon is 85.7, we know add them up is 100%. So this compound is only made by hydrogen and carbon. And then we can do the ratio, okay? The ratio between hydrogen and carbon, and please pay attention, the ratio here refers to the quantity of hydrogen versus the quantity of carbon. So remember, the quantity of moles equals to the mass divides molar mass. So we need to use the mass percent divides the molar mass of the corresponding element. So hydrogen to carbon ratio in quantity equals to 14.3, the mass percent of hydrogen, divides 1 gram per mole, the molar mass of hydrogen, to 85.7, the mass percent of carbon, divides 12 gram per mole, the molar mass of carbon. Then you can get two numbers, okay? This is not a whole number ratio, and we want to simplify that. The way to do it is divide each part of the ratio by the smallest number. In this case, it's 7.142. Use 14.3 divide 7.142, you get 2.002. 7.142 divides 7.142 equals to 1. So by doing that calculation, we now have 1 in the ratio. So it's 2.002 to 1. And now finally, we need to run off to have a whole number ratio. So it's 2 to 1. And that's the empirical formula CH2. All right, let's practice it through a question. Find the empirical formula for each of the following compounds. Let's take a look at them one by one. A, 0.063 mole of chlorine atoms combined with 0.22 moles of oxygen atoms. Remember, all the ratios we talk about in the empirical formula, it's about quantities. It's never about mass. It's always about quantities. Okay, so chlorine to oxygen, the ratio, we can just use a quantity in the moles, right? It's just different unit. So chlorine to oxygen is 0.063 mole to 0.22 mole. Simplify that by divides over the smallest number, 0.063 moles in both parts. We can simplify the ratio as 1.3492. Okay, now here's a tricky part. 3.492, if you run it off to keep 1 digit after decimal, is 3.5. 3.5, it's, if you say it as 3 or 4, it's kind of, the error is too big, right? So once we have this values, which is not that easy to run off to integers, or it's kind of sitting in between of two integers, we multiply everything by 2, duplicate that. Or if the duplication does not work, we can multiply it by 3 or 4 until you get the smallest value that close to an integer. So in this case, we multiply both case by 2, so it becomes 2 to 6.984. Okay, 6.984, I'm very comfortable in running it off to 7. So that will be our final answer. The chlorine to oxygen is 2 to 7. That's our empirical formula, chlorine to oxygen 7. For second question, B, there are 2.45 grams of silicon combined with 12.4 grams of chlorine. In this case, remember we talk about quantities, but it's provided by the mass. So we need to, get the quantity from the mass using the molar mass equation. Get number of moles. Mass equals to molar mass times number of moles. We can get the molar mass of these two elements from periodic table. Then calculate the number of moles. So for silicon, it's 0.0875 mole. And for chlorine is 0.3498 mole. Okay, now we can do the ratio of silicon and chlorine. Plug in the numbers, divide both parts by the smallest number. In this case is 0.0875. Sometimes when you have three elements, you need to pick the smallest one. So in this case, it's a smaller, divides a smaller number. Okay, so then you can simplify this ratio to 1 to 3.998. And for this number, I'm very comfortably in running it off to 1 to 4. Now, the final answer is silicon, chlorine 4. For last question, it provides you the mass percent of the two different elements. Again, like the thing is question B, we need to get the ratio, but in order to calculate the molar mass, we need to use the mass percent in the ratio, so we don't get the actual moles, we just get the ratio of moles. And also, if you add these two numbers together, it's 100%. So this empirical formula only have carbon and oxygen. Find the molar mass of these two in the periodic table, and then do the ratio in quantity. So in this case, we don't calculate the specific moles because we only know the mass percent instead of the actual mass. We can plug in the mass percent on top. So for carbon, it's 27.3 divides 12, the molar mass of carbon. And then for oxygen, it's 72.7 divides 16, which is the molar mass of oxygen. Then you get two numbers, divide two numbers with a smaller number. In this case, it's 2.275. Then you can get the ratio is 1 to 1.997. For the second number, we can run it off to 2. So the final answer is 1 to 2. It's carbon dioxide. All right, this is the end of the video talking about formula calculations. I'll see you in next video. Bye.